Alrighty guys, this is part 2 of 4.7. If you haven't watched part 1 yet, or you weren't in class yesterday, I put a link to 4.7 part 1 in the description below. So check that out first before watching this video. So, I want to do a little review before we do get into it. So, we were talking about quadratics, right? And what was our quadratic equation? Well, it was this right here. F of x is equal to ax squared plus bx plus c. And that is our standard equation. Next, we had some things we wanted to talk about. So our a, right? If it was positive, some things we should know. It is a U-shaped, which means it's going to open up. Our a is positive, so it's opening up towards positive infinity. And finally, our vertex is going to be a minimum, okay? Because if we look, our vertex is at the very bottom, so it's going to be a minimum. Conversely, if our a is negative, so the coefficient of x squared is negative, it's going to be upside down U-shaped, opens down towards negative infinity, and our vertex is a max. All right? Then we had a line that we could draw right down the middle, and it divided our parabolas up into two equal parts, and we called this the axis of symmetry. And the axis of symmetry is an equation x equals some number. Whatever that number is that perfectly divides our parabolas in half. From here, we were able to take our axis of symmetry, and since it was x equals something, and plug it in for x to find our y value, and this was called our vertex, right? Our maximum and minimums, and it's the bottom or top of our parabola. So by plugging in the x we found from the axis of symmetry, we found our vertex. All right? And then we were able to do a problem and figure out what our if it was a maximum or minimum, what our axis of symmetry was, and what our vertex was. We were then able to take that and draw a rough sketch, but it wasn't fine-tuned. In the math, we like to be precise. So that's what this lesson is going to be all about. So this is lesson 4.7b, or part 2, graphing our quadratics, okay? So, how do we think we graph our parabola? Well, first let's think back to our absolute value. Where did we start? Our vertex. Well, looky here, we have vertexes here. So that's where we want to start, all right? How do we find the vertex? Like I said, we find the axis of symmetry, which we said was negative b over 2a. So we plug in a, we plug in b, we get some number, and then it's going to be x equals that number. We then plug that number in for x, and we can find our f of x or our y value. This gives us a vertex, and that's where we want to start. So now we have found our vertex, and we want to graph the rest of our parabola. Well, instead of just drawing curves, what do you think we can do to figure that out? Think back to our absolute value when we originally graphed. What did we do? That's right. We made an f of x table, or xy, whatever you want to call it. All right? Just like the vertex of our absolute value, right? We want to plug our vertex in here. Our vertex is going to be our middle number, or middle ordered pair, and then we're going to pick x's above and below our x value of a vertex, and then plug those numbers into our f of x, get out outputs, and then we can connect those with a sort of curve. All right? So right now, the steps are being presented to you. It's find the axis of symmetry in the vertex, Place the vertex in the middle row of your XY table, number up, number down, complete the table, and then finally graph it. So we have our first equation, which is going to be f of x is equal to negative 3x squared. Okay? And I want to graph the function and find the domain and the range. So, find the vertex. How do we find the vertex? We find the axis of symmetry. So what is my A? Well, my A is negative 3. What is my B? 0. So I plug in 0, 0, negative 0 over negative 6 is still 0. So my middle number is going to be 0. I then plug that in. 0 squared is 0 times negative 3, also 0. Okay? Then I start plugging in, or I pick numbers for x. I'm going to do negative 1, negative 2, 1, 2. All right. So then I start plugging in my numbers. Negative 1 squared is 1 times negative 3, negative 3. Negative 2 squared is 4 times negative 3, negative 12. 1 squared, 1 times negative 3, negative 3, negative 12. And that makes sense, right? We said they're symmetrical. So these should match. There should be symmetry. So we start at 0, 0. We then go to negative 1, 2, 3, positive 1, 3, negative 2, 12, positive 2, negative 12, and connected. And that is how we properly graph our quadratic equations. So now I have to ask myself, what's my domain? What's my range? So my domain, what can I plug in for x and get something out? Well, I can plug in all real numbers, right? So my domain is going to be all real numbers. What is my range? Well, we can see I go all the way down to negative infinity, but I have a maximum of 0. So my range, and do not forget these curly Q's, all right? These brackets are important. It's the difference between an equation and a set of numbers. So my equation is y, my range is y, such that y is less than or equal to 0. And that would be the entire number 5. So I want you to look at number 6, give that one a shot, and see how you do. Alrighty, hopefully you gave number 6 a shot. You found the vertex to be at 3, 2. Plugged in 2, 1, 0, 4, 5, 6. Plugged them in, got something that looks like this. Graphed it. Found your domain to be all real numbers, and your range is y such that y is greater than or equal to 2. All right, so let's move on to the next one. All righty, so on to number 7, we have f of x is equal to 2x squared minus 8x plus 6, right? So first thing we got to do, find our axis of symmetry. So we have x equals negative b, so negative of negative 8 is going to be positive 8 over 2a, 2 times 2 is 4, that is going to be equal to 2. All right, so I know my axis of symmetry is at 2. I then plug that in. So we get 2 times 2 squared minus 8 times 2 plus 6. 2 squared is 4, times 2 is 8, minus 8 times 2 is 16, plus 6, combine those, I get negative 8 plus 6, which equals negative 2. So my order pair of 2, negative 2 is my vertex. If I come to my table, 2, negative 2, 1, 0, negative 1, 3, 4, 5. I'm going to plug those values in. Let's see, 1, get 2 minus 0. Luckily it's symmetrical, so I don't need to do any math for that. Plug in 0, I get 6. That's a nice easy one. So that's going to be 6. Negative 1, you're going to get 2 plus 8 plus 6, 16. Okay. And now I have enough points to graph my equation. So I'm going to go with a 2, negative 2, put my vertex. Going to 1, 0, 3, 0. Going to 0, 2, 3, 4, 5, 6, 6, 14, 15, 16, 16, and then I make my graph. All right. Hopefully you're able to follow along. Almost forgot. What is our domain? Well, our domain is all real numbers. We can plug in any x and we'll get something out. What is our range? Well, we know that is a minimum. So it's going to be y such that y, and since it's a minimum, it's going to be greater than or equal to. And what's our minimum? It's negative 2, right? So that is our range. That is our problem. Let's move on to the next one. Number 8. Give that one a shot and then see how you did. Alrighty. I'm actually going to skip 9. Go ahead and give that a shot yourself. I'll present the answer now. Pause the video, look at that. I'm going to move on to 10 because it's a piecewise function. I kind of want to go over this again. I feel like some of you still were struggling. So a piecewise function is a function with 2 or more functions. And each of those functions has a domain restriction. So I can only use x less than negative 4 for this equation. X greater than or equal to negative 4, it goes into this equation. So if I were to say use the number 0, that is in this domain, so I would only use this equation. All right? So, still make an XY table. Let's go ahead and get the easier one out of the way. Where do I start my XY table? Well, I start it at my domain restriction. So my domain restriction is negative 4, negative 5, negative 6, right? We'll even do negative 7. All right, because it is less than negative 4. So it's all numbers less than negative 4. So I plug that in. Negative 4 times 2 is negative 8, plus 5 is going to be negative 3. Plug in 5, I get negative 10, negative 5. Plug in 6, I get negative 12, negative 7, negative 9. All right? So I go to my first ordered pair, negative 4, negative 3. Negative 4, 1, 2, 3, 4, 1, 2, 3. Here I put an open circle because x is strictly less than negative 4, right? And I go to my other points, here, 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 draw my line, draw my arrow. That easy one is done. Next, I still want to find my vertex, right? So where's my vertex going to be? So my A is 1, my B is 3. I get negative 3 over 2, which is going to be equal to negative 3 over 2. It's just done, that it is. So negative 3 over 2 is negative 1.5. So my vertex is in my domain. So still want to put that, negative 3 over 2. And that's between negative 1 and negative 2. So negative 2, negative 3. And then negative 4 is where I want to stop conveniently. works with how many points I have because that's the end of my domain restriction. I then plug in -1, 0, 1. And I plug in and I get my value. So, plug in -3/2. -3 squared, or -3 over -2 squared is going to be 9/4 minus, and then 9 times, or it's going to be 9/2, right? That's going to give me -9/2 as a vertex. So my 9/2, that's 1, 2, 3, 4.5. So there's my vertex. Did I do that right? Nope, because it's 9/4. I'm sorry. So my vertex is actually going to be at -2.25. In case you're wondering where I got that from, 9/2 you gotta get, or 9/4 you gotta get like bases, so you multiply that by 2/2, and that's how you get that. All right. So there's my vertex. Now I start plugging in numbers. -2 squared is 4. 4 times -3, or I'm sorry, 3 times -2 is -6. So -2. 3, I get 9 minus 9, which is 0. I get 4. I get 16 minus 12, which is 4. Okay? So I can plug in those points. I get -2, 0, 1, 2, 3, 4. And now, because of this, it gets a closed circle. Okay? And then conveniently, because that is a half, this is going to work out to be exactly the same. So I go here, I go here, and I go here, and draw my vertex, but I stop at that dot, right? Because my domain doesn't, for my x squared, my quadratic, doesn't go any further left, so it stops at that dot, but that side does get an arrow. So, what is my domain? Well, I can plug in anything and get something out, so it's all real numbers. But what is my range? Well, we can see that this range is -4, or I'm sorry, -3, right? And below. So how do we say that? Y such that y is less than -3, and it's strictly less than because it's an open circle, okay? But I have another range. How do I say that range? Union, remember way back in chapter 1, right? Way back in chapter 1 when we were doing less than and greater than and ends and ors. So, union y greater than or equal to, and then what do we say? -2.25. And that whole thing is my range. Alright. Hopefully now you should be pretty comfortable with how to graph these, right? Just follow our steps like we did in the last section. Find the axis of symmetry, decide if it's a maximum or minimum, plug in our axis of symmetry, get our vertex, and then we're able to get the general shape. But now we just create a table and get from a general shape to a very specific shape. So hopefully this helped you. If you didn't, send me an email anytime. I'd be more than happy to help. Otherwise, we're going to move on to the next lesson. Hope this helps.